This is Algebra 2 with Trig, 8B.4d. We're going to talk about evaluating inverse trig functions. So we're going to use sine inverse, cosine inverse, and tangent inverse to solve for an angle. You're solving for theta. So what that's going to mean is we're looking for a value, an angle value, that represents, for example, where sine is a half. So if I put together this circle and I think about sine of what angle is going to equal a half. So a half for sine is going to be when I'm up a short distance. So that means I'm going to be here at root 3 over 2, 1/2. Now I could also be over here where my sine is still 1/2. My cosine is different, but my sine is still 1/2. Every answer is going to really have two locations. But we're only going to want this location as an answer. So we're going to talk about theta is going to be sine inverse of a half. And since we know sine is a half when theta is 30 degrees, our theta is going to be 30 degrees, otherwise known as pi over 6. So that's essentially what our lesson is today. What angle gives us our different coordinates that we've already learned about on the unit circle? We can give answers in degrees and we can give answers in radian. But then there's this whole part about, but there are two answers that have the same result. How do we know which answer to give? We're going to go over that. So inverse trig functions allow us to find a value of theta corresponding to a given value. In order to obtain a unique angle, a unique theta, not have two answers but only have one answer, we have to restrict the domain of the original trig functions. So let's think about here for a moment, where is sine of theta positive? Sine of theta is positive in both of these quadrants. Sine is a y value, and y is positive in both the first and second quadrant. Well, we're always going to consider positiveness to be in the first quadrant. So we're always going to deal with the first quadrant for every trig function. Anytime we're dealing with a positive, we're going to be looking for answers in the first quadrant. So that's why our answer here fell inside the first quadrant at 30 degrees. We're not going to consider 150 to be our answer for sine, because we want all positive answers to be in the first quadrant. Now, how about a negative sine answer? Sine is negative in these two quadrants, quadrants 3 and 4. It's helpful for when we're looking at our angle values to be consistent next to each other, that we don't want to look at two quadrants that are across from each other. We want them to be next to each other. So when we talk about a negative sine value, we're going to talk about being down here in the negative quadrant, or maybe you call it the fourth quadrant, but the angles cannot be greater than 90. The angles are going to be negative angles. So when we're talking about theta, so theta is going to equal sine inverse of our value that we're dealing with. We'll call it an A value. But for the value that we're dealing with, we're going to be looking for values either in the first quadrant or the fourth quadrant, but this fourth quadrant, you're going to have answers that are negative. So we're going from 0 to negative pi over 2 down here in the fourth quadrant, and 0 up to pi over 2 in the first quadrant, or 90 degrees and negative 90. For cosine, where is cosine positive? Well, we're only going to look for answers in the first quadrant for positiveness, so that's simple. Now, where is cosine negative? Cosine is an x value. Cosine is negative in both the second and third quadrant. So we're going to be looking for answers in the second quadrant for cosine. We have a positive in the first quadrant. It's also positive down here in the fourth, but we're not interested in that one. We want the positives to be in the first and also the positives to be in the second, because we want our two quadrants to be next to each other. So we're looking at answers from 0 all the way to pi, or from 0 all the way to 180. We don't have any negative answer for cosine. Here we had a negative angle when we came down into the fourth quadrant. We're not counting numbers that go greater than 90. We don't come over here through the 180, past the 270. We only use negative angles. Here we'll never have a negative result. We'll always have up to 90 and then past 90 to 180. Then tangent. Well, tangent can be positive, of course, and that we've decided will always be in the first quadrant. So that's from 0 up to pi over 2, 90 degrees. Now, what gets a little complicated here is that tangent is negative in both of these quadrants, which means they're next to them in both. So we could theoretically come on over and make it very similar to what cosine is. Or we could bring it down here and make it very similar to what sine is. And we're going to come here and we're going to look for answers in the first and fourth quadrant down to negative pi over 2, because tangent exists at 0 degrees. So now we have this shaded in region and 0 exists. If we would have come up over the top, had this coordinate here at 0, 1, tangent at 0, 1 would be 1 over 0. That's undefined. We don't want to consider tangent going through an angle that produces an undefined value. So we're going to go from pi over 2 to negative pi over 2 because it exists at 0. All right. Here it kind of gives the same explanation we just talked about. Sine is from negative 90 to 90. Cosine is from 0 to 180. And tangent, notice that they don't have equal to. And the reason they don't have equal to is because it's undefined on the y-axis. So we can only go up to that spot. We'll never have an angle exactly on the y-axis because it's undefined. Tangent is undefined at 90 degrees or negative 90. Sine and tangent have negative values that imply a negative angle. So if we come down here and have a negative tangent, we're going to get negative angles. Not large angles, but negative angles. Cosine, however, a negative value implies that it's in the second quadrant. If you have a negative x, you're just going to be at an angle that's bigger than 90 degrees. So tangent gives you an obtuse angle, but sine and cosine would never give you an angle bigger than 90 degrees. So let's go ahead and try one of these. These are inverse functions. So sine inverse, that tells us that we're looking for the angle that has a sine at -1. So you need to visualize your unit circle. And we look at all our quadrantal angles here. We're at 1, 0 when we go to the right. We're at 0, 1 when we're going up. -1, 0, but that's a cosine value, 0 for sine. And 0, -1 when we're coming down. So the angle has to be pointing in this direction. So we're looking at 90 degrees going up or -90 degrees coming down. So this has to be -90 degrees. Or you could give the answer as -pi/2 because we want answers in these two quadrants. We don't want to consider going past 90 degrees to come all the way around into the 300s. We have to do less than 0 degrees, which is negative. Negative √2/2. So think about your unit circle. Where is cosine? Negative √2/2. Well, that's going to be off in this direction. We have negative √2/2. We have positive √2/2. That's the coordinate. Now, whenever we see √2/2, what type of angles do we think about? 45. We think about 45-degree angles. So we know that we're pointing exactly at a 45-degree angle. So we know that this is going to be 135. Now, do realize that it is possible to have an answer down here be negative √2/2 for cosine. It's going to be negative √2/2 for sine. But the cosine is still negative √2/2. But that's not inside the shaded region where we give appropriate answers for cosine. For radian, we would be 1/4, 2/4, 3/4. So 3π/4. 45s always go by fourths because there are 4 times 45 to get to 180. To get to pi, this is 3/4 of the top half circle. Tangent of √3/3. Where is tangent √3/3? Now, tangent's always a little bit trickier because you now have to manipulate what the coordinates are. Now, we've talked about how tangent, when you have the 3 on bottom, √3/3 is going to be a 30-degree angle. At 60, it's just going to be the √3. But when you're 30 degrees away from the x-axis, you're always going to be √3/3. If you don't remember that, then you have to consider what the coordinate is. And if that's the coordinate, then you do your y over your x. So that's 1/2. That's not a y. That's a 1/2. It's the y value. And that means that you're going to take your half and times it by the reciprocal, which crosses the 2's out. And then you have to rationalize the denominator to get √3/3. So this angle here has a short y and a long x. That tells us it's going to be at 30 degrees or pi/6. Where is sine -1/2? So we make our unit circle. Where is sine ½ -1/2 is going to come down. So we're over here at √3/2 -1/2. Now remember, it does also occur over here in the third quadrant. at negative root 3 over 2, negative 1/2, but we only look for answers in the first and fourth quadrant. We only look for answers that are between negative 90 and positive 90. We don't want an answer that says 330. So the correct answer here is to say negative 30 or negative pi over 6. So cosine at a half. To do cosine as a half, that's going to happen in two different spots. That'll happen out here at a half root 3 over 2. And remember, cosine is going to be in your first two quadrants. So we're going to use 60 degrees or pi over 3. And then tangent. For tangent to be negative 1, remember, tangent's going to be in your first quadrant or your fourth quadrant. To be a negative, of course, it has to be in the fourth quadrant. The coordinates at negative root, actually that's a positive for x. The x value here is positive root 2 over 2, negative root 2 over 2 for the sine. And when you do that fraction of sine over cosine, you get a value of negative 1. So that's going to happen at negative 45 or negative pi over 4. Remember, we don't want answers at 315 unless it asks us for answers between 270 and 360. We want answers that are going to fall between negative pi over 2 and pi, or negative 90 and 90 when we talk about tangent or sine. Cosine's a little bit more straightforward. We want answers between 0 and pi or 0 and 180. All right, we're going to try a few more of these. Where is cosine negative root 3 over 2? Well, it's negative when you move to the left. So that's going to happen at 150 degrees or 5 pi over 6. Where is sine 2? That never happens. Sine cannot be 2. There is no spot where sine is going to be greater. Oh, I'm sorry. It's root 2, not the number 2. If it was sine of 2, which will come up somewhere, like in your notes or in your homework, there is no solution to that. But this is root 2. Where is sine root 2? All right. This does not say 2. It says root 2. But just for our knowledge, root 2 is still greater than 1. So this is still no solution. There is no spot that sine can ever be greater than 1. Negative root 3. Well, that's going to happen. Remember, tangent happens in the first and the fourth quadrant. That's going to happen when you're 1/2 comma negative root 3 over 2. So when you take your root 3 over 2 and multiply by the reciprocal, you get the negative root 3. So that happens at negative 60 or negative pi over 3. Now we can do some of these calculations with our calculator. for values that are outside of the, not our normal angle values or special angles. Sine inverse, what angle gives us a point 42? And that would be a 24-degree angle. What angle gives us a tangent of negative 1.7? And that's a negative 59-degree angle. And what cosine gives us a negative 0.83 degree angle? And that's going to be 146. Remember, that's going to put us in the second quadrant.